I don't think I've said this publicly before, but I just called Lachy and was like, look, Lachy, like if this doesn't have PMF by the end of the year, like we'll just like return all the money to you. Justine and I don't want to work on this unless it's really working. So we want to give it the best shot this year. And like, we're really going to go for it. We're going to hire a bunch of people and we're just going to be honest with everyone. Like when I don't know how to play a game, I just play with open cards. Lachy was the only person that didn't freak out. He was like, I've never heard anyone say that before.
Hey everyone, welcome to the Latent Space podcast. This is Alessio, founder of Kernel.ets, and I'm joined by Swix, editor of Latent Space.
Hello. We're recording in the Kernel studio for the first time. Very excited. And today we're joined by Hørup Eskildsen of Turbopuffer. Welcome.
Thank you so much for having me.
Turbopuffer has like really gone on a huge tear, and I do have to mention that like you're not my newest member of the Danish Aarhus Mafia, where like there's a lot of legendary programmers that have come out of it, like Bjørn Strostrup, Rasmus Lerdorf, Anders Halsberg, and the V8 team and Google Maps team. You're mostly like Canadian now, but isn't that interesting? There's so much like strong Danish presence.
Yeah, I was writing a post not that long ago about sort of the influences. So I grew up in Denmark, right? I left when I was 18 to go to Canada to work at Shopify. And so I would still say that I feel more Danish than Canadian. This is also the weird accent. I can't say TH because this is like, my wife is also Canadian. And I think like one of the things in Denmark is just like, there's just such a ruthless pragmatism. And there's also a big focus on just aesthetics. Like they're like people really care about like what things look like. And like Canada has a lot of attributes, US has a lot of attributes, but I think there's been lots of great things to carry. I don't know what's in the water in Aarhus though. And I don't know that I could be considered part of the Aarhus Mafia quite yet, compared to the phenomenal individuals you just mentioned. But Rasmus Lerdorf is also Danish-Canadian.
Okay.
Yeah, I don't know where he lives now, and he's the PHP.
Yeah, and obviously Toby, German, but moved to Canada as well. Like this is like import that is interesting talent move.
I think I would love to get from you the definition of Turbopuffer, because I think you could be a vector DB, which is maybe a bad word now in some circles. You could be a search engine. It's like, let's just start there, and then we'll maybe run through the history of how you got to this point.
For sure. Yeah. So Turbopuffer is at this point in time a search engine, right? We do full text search and we do vector search. And that's really what we're specialized in. If you're trying to do much more than that, like then this might not be the right place yet. But Turbopuffer is all about search. The other way that I think about it is that we can take all of the world's knowledge, all of the exabytes and exabytes of data that there is, and we can use those tokens to train a model. But we can't compress all of that into a few terabytes of weights, right? We can compress into a few terabytes of weights how to reason with the world, how to make sense of the knowledge, but we have to somehow connect it to something external that actually holds that like in full fidelity and truth. And that's the thing that we intend to become, right? That's like a very holier than thou kind of phrasing, right? But being the search engine for unstructured data is the focus of Turbopuffer at this point in time.
And let's break down. So people might say, well, didn't Elasticsearch already do this? And then some other people might say, is this search on my data? Is this like closer to RAG than to like a EXA or like a public search thing? Like how do you segment like the different types of search?
The way that I generally think about this is like, there's a lot of database companies. And I think if you want to build a really big database company, you need a couple of ingredients to be in the air, which only happens roughly every 15 years. You need a new workload. You basically need the ambition that every single company on Earth is going to have data in your database multiple times. You look at a company like Oracle, right? I don't think you can find a company on Earth with a digital presence that doesn't somehow have some data in an Oracle database, right? And I think at this point, that's also true for Snowflake and Databricks, right? 15 years later, or even more than that. There's not a company on Earth that doesn't indirectly or directly is consuming Snowflake or Databricks or any of the big analytics databases. And I think we're in that kind of moment now, right? I don't think you're going to find a company over the next few years that doesn't directly or indirectly have all their data available for search and connected to AI. So you need that new workload. Like you need something to be happening where there's a new workload that causes that to happen. And that new workload is connecting very large amounts of data to AI. The second thing you need, the second condition to build a big database company, is that you need some new underlying change in the storage architecture that is not possible from the databases that have come before you. If you look at Snowflake and Databricks, right, commoditized like massive fleet of HDDs, like that was not possible it just wasn't in the air in the 90s, right? So we just didn't build these systems. S3 and so on was not around. And I think the architecture that is now possible, that wasn't possible 15 years ago, is to go all in on NVMe SSDs. It requires a particular type of architecture for the database that is difficult to retrofit onto the databases that are already there, including the ones you just mentioned. The second thing is to go all in on object storage, more so than we could have done 15 years ago. Like, we don't have a consensus layer. We don't really have anything. In fact, you could turn off all the servers that Turbopuffer has, and we would not lose any data because we have completely all in on object storage. And this means that our architecture is just so simple. So that's the second condition, right? First being a new workload. That means that every company on earth, either indirectly or directly, is using your database. Second being there's some new storage architecture. That means that the companies that have come before you can't do what you're doing. I think the third thing you need to do to build a big database company is that over time, you have to implement more or less every query plan on the data. What that means is that you can't just get stuck in like, this is the one thing that a database does. It has to be ever evolving, because when someone has data in the database, they over time expect to be able to ask it more or less every question. So you have to do that to get the storage architecture to the limit of what it's capable of. Those are the three conditions.
I just wanted to get a little bit of like the motivation, right? Like, so you left Shopify, you were like principal engineer, infra guy. You were also head of kernel labs inside of Shopify, right? And then you consulted for Readwise, and that kind of gave you that idea. I just wanted you to tell that story. Maybe you've told it before, but just introduce the people to like the new workload, the sort of aha moment for Turbopuffer.
For sure. So yeah, I spent almost a decade at Shopify. I was on the infrastructure team from the fairly early days, around 2013. At the time, it felt like it was growing so quickly, and everything, all the metrics were, doubling year on year. Compared to what companies are contending with today, it's very cute growth. I feel like some companies are seeing that month over month. Of course, Shopify has been compounding for a very long time now. But I spent a decade doing that. And the majority of that was just make sure the site is up today and make sure it's up a year from now. And a lot of that was really just the Kardashians would drive very, very large amounts of data to Shopify as they were rotating through all the merch and building out their businesses. And we just needed to make sure we could handle that, right? And sometimes these were events with 1 million requests per second. And so, we had our own data centers back in the day, and we were moving to the cloud, and there's so much sharding work and all of that we were doing. So I spent a decade just scaling databases, because that's fundamentally what's the most difficult thing to scale about these sites. The database that was the most difficult for me to scale during that time, and that was the most aggravating to be on call for, was Elasticsearch. It was very, very difficult to deal with. And I saw a lot of projects that were just being held back in their ambition by using it. And I mean,
self-hosted.
Self-hosted,
because
yeah. And there's also, this was like 2015, right? So it's like a very particular vintage, right? It's probably better at a lot of these things now. It was difficult to contend with. And I just think about it. It's an inverted index. It should be good at these kinds of queries and do all of this. And we often couldn't get it to do exactly what we needed to do, or basically get Lucene to do, like expose Lucene raw to what we needed to do. So that was like just something that we did on the side, and just panic scaled when we needed to, but not a particular focus of mine. So I left. And when I left, I wasn't sure exactly what I wanted to do. I mean, I'd spent like a decade inside of the same company. I'd like grown up there. I started working there when I was 18.
You only do Rails.
Rails. And
he's a Rails guy.
Love Rails. So good.
We all wish we could still work in Rails.
I know. But
I tried learning Ruby. It's just too many options to do the same thing. That's my... I know there's a way to do it.
I love it. I don't know that I would use it now, like given Claude Code and Cursor and everything. But still, like if I'm just sitting down and writing a seasonal code, that's how I think. But anyway, I left, and I talked to a couple companies, and I was like, I need to see a little bit more of the world here to know what I'm gonna like focus on next. And so what I decided is like I called it like angel engineering, where I just hopped around in my friends' companies in 3 months increments and just helped them out with something, right? And just vested a bit of equity and solved some interesting infrastructure problem. So I worked with a bunch of companies at the time. Readwise was one of them. Replicate was one of them. Causal, I don't know if you've tried this. It's like it's a spreadsheet engine, where you can do distribution. They sold recently, we used that in FP&A at Turbopuffer. So a bunch of companies like this, and it was super fun. And so when the ChatGPT moment happened, I was with Readwise for a stint. We were preparing for the reader launch, right, which is where you queue articles and read them later. And I was just getting their Postgres up to snuff, which basically boils down to tuning auto vacuum. So I was doing that, and then this happened, and we were like, oh, maybe we should build a little recommendation engine and some features to try to hook in the LLMs. They were not that good yet, but it was clear there was something there. And so I built a small recommendation engine, just, okay, let's take the articles that you recently read, right? Like, embed all the articles and then do recommendations. It was good enough that when I ran it on one of the co-founders of Readwise, I found out that I got articles about having a child. I'm like, oh my God, I didn't know that they were having a child. I wasn't sure what to do with that information, but the recommendation engine was good enough that it was suggesting articles about that. And so there was recommendations, and it actually worked really well. But this was a company that was spending maybe $5,000 a month in total on all of their infrastructure. And when I did the napkin math on running the embeddings of all the articles, putting them into a vector index, putting it in prod, it's going to be like $30,000 a month. That just wasn't tenable, right? Like, Readwise is a proudly bootstrapped company, and paying $30,000 for infrastructure for one feature versus 5, it just wasn't tenable. So it's sort of in the bucket of, this is useful, it's pretty good, but let's return to it when the costs come down.
Did you say it grows by feature? So from 5 to 30 is by the number of, what's the scaling factor? It scales by the number of articles that you embed.
It does, but what I meant by that is $5,000 for all of the other, the Heroku Dynos, Postgres, all the other, and this
then storage is 30.
Yeah, and then $30,000 for one feature, right? Which is what other articles are related to this one. So it was just too much, right, to power everything. Their budget would have been maybe a few $1,000s, which still would have been a lot. And so we put it in the bucket of, okay, we're going to do that later. We'll wait for the cost to come down. And that haunted me. I couldn't stop thinking about it. I was like, okay, there's clearly some latent demand here. If the cost had been a tenth, we would have shipped it. And this was really the only data point that I had, right? I didn't go out and talk to anyone else. It was just, so I started reading, right? I couldn't help myself. I didn't know what a vector index is. I generally barely knew about how to generate the vectors. There was a lot of hype about, this is early 2023. There was a lot of hype about vector databases. They're raising a lot of money. And I really didn't know anything about it. It's trying these little models, fine tuning them. I was just trying to get sort of a lay of the land. So I just sat down. I have this GitHub repository called Napkin Math. And on Napkin Math, there's just rows of oh, this is how much bandwidth, this is how many, you can do 25 gigabytes per second on average to DRAM. You can do, 5 gigabytes per second of writes to an SSD, blah, blah, all of these numbers, right? And S3, how much bandwidth can you drive per connection? I was just sitting down. It's why hasn't anyone built a database where you just put everything on object storage, and then you puff it into NVMe when you use the data, and you puff it into DRAM if you're querying it a lot. It's just this seems fairly obvious. And the only real downside to that is that if you go all in on object storage, every write will take a couple hundred milliseconds of latency. But from there, it's really all upside, right? You do the first query, it takes half a second. And it sort of occurred to me as well, the architecture is really good for that. It's really good for object storage. It's really good for NVMe SSD. You just couldn't have done that 10 years ago, back to what we were talking about before. You really have to build a database where you have as few round trips as possible, right? This is how CPUs work today. It's how NVMe SSDs work. It's how S3 works, that you want to have a very large amount of outstanding requests, right? Basically go to S3, do that 1,000 requests to ask for data in one round trip, wait for that, get that, make a new decision, do it again, and try to do that maybe a maximum of 3 times. But no databases were designed that way. With NVMe SSDs, you can drive within a very low multiple of DRAM bandwidth if you use it that way. And same with S3, right? You can fully max out the network card, which generally is not maxed out. You get very, very good bandwidth. But no one had built a database like that. So it's okay, well, can't you just, take all the vectors, right, and plot them in the proverbial coordinate system, get the clusters, put a file on S3 called clusters.json, and then put another file for every cluster, cluster1.json, cluster2.json. it's 2 round trips, right? So you get the clusters, you find the closest clusters, and then you download the cluster files, like the closest end, and you could do this in 2 round trips.
You run nearest neighbors locally.
Yes. And you would build this file, right? Just like ultra simplistic, but it's not a far shot from what the first version of Turbopuffer was. Why hasn't anyone done that?
In that moment, from a workload perspective, you're thinking this is going to be like a read heavy thing because they're doing recommended. Like, is the fact that like writes are so expensive now? Oh, with AI, you're actually not writing that much.
At that point, I hadn't really thought too much about, well, no, actually, it was always clear to me that there was going to be a lot of writes because at Shopify, the search clusters were doing, I don't know, tens or hundreds of QPS, right? Because you have to have a human sit and type in. But we did, I don't know how many updates there were per second. I'm sure it was in the millions, right, into the cluster. So I always knew there was like a 10 to 100 ratio on the read-write. In the Readwise use case, it's even in the Readwise use case, there'd probably be a lot fewer reads than writes, right? There's just a lot of churn on the amount of stuff that was going through versus the amount of queries. I wasn't thinking too much about that. I was mostly just thinking about what's the fundamentally cheapest way to build a database in the cloud today using the primitives that you have available. And this is it, right? Now you have one machine and, let's say you have a terabyte of data in S3, you paid $200 a month for that. And then maybe 5 to 10% of that data needs to be in NVMe SSDs and less than that in DRAM. Well, you're paying very, very little to inflate the data.
By the way, when you say no one else has done that, would you consider Neon to be on a similar path in terms of being sort of S3 first and separating the compute and storage?
Yeah, I think what I meant with that is just build a completely new database. I don't know if we were the first. Like, it was very much, I just looked at the napkin math and was like, this seems really obvious. So I'm sure like 100 people came up with it at the same time, like the light bulb and every invention ever, right? It was just in the air. I think Neon was first to it, and they're retrofitted it onto Postgres, right? And then they built this whole architecture where you have it in memory, and then you sort of like, mmap back to S3. And I think that was very novel at the time to do it for OLTP. But I hadn't seen a database that was truly all in, right? Not retrofitting it. The database built purely for this, no consensus layer, even using compare and swap on object storage to do consensus. I hadn't seen anyone go that all in. And I'm sure there's someone that did that before us. I don't know.
Yeah,
I was just looking at the napkin math.
And when you say consensus layer, are you strongly relying on S3 strong consistency? You are. Okay. So that is your consensus layer?
It is the consistency layer. And I think also, like, this is something that most people don't realize, but S3 only became consistent in December of 2020.
I remember this coming out during COVID, and like people were like, "Oh, like it was like it was just like a free upgrade."
Yeah,
they just announced it. We saw consistency, guys, and like, okay, cool.
And I'm sure that they probably had it in prod for a while. They're just like, it's done, right? And people are like, okay, cool. But that's a big moment, right? Like NVMe SSDs were also not in the cloud until around 2017, right? So you just sort of had like 2017 NVMe SSDs, and people were like, okay, cool. There's like one SKU that does this, whatever, right? It takes a few years. And then the second thing is like S3 becomes consistent in 2020. So now it means you don't have to have this like big foundation DB or like Zookeeper or whatever sitting there contending with the keys, which is how, that's what Snowflake and others that have
so
to do.
Much infra gone.
Exactly, just gone, right? And so just push to the, whatever, how many hundreds of people they have working on S3, solved. And then compare and swap was not in S3 at this point in time.
By the way, I don't know what that is, so maybe you want to explain.
Yes,
yeah.
Yes. So what compare and swap is basically, you can imagine that if you have a database, it might be really nice to have a file called metadata.json. And metadata.json could say things like, hey, these keys are here, and this file means that, and there's lots of metadata that you have to operate in the database, right? But that's the simplest way to do it. So now you might have a lot of servers that want to change the metadata. They might have written a file and want the metadata to contain that file. But you have 100 nodes that are trying to contend with this metadata.json. Well, what compare and swap allows you to do is basically just you download the file, you make the modifications, and then you write it only if it hasn't changed while you did the modification. And if not, you retry, right? You just have this retry loops. Now you can imagine if you have 100 nodes doing that, it's going to be really slow, but it will converge over time. That primitive was not available in S3. It wasn't available in S3 until late 2024, but it was available in GCP. The real story of this is certainly not that I sat down and like big brained it. I was like, okay, we're going to start on GCS. S3 is going to get it later. Like, it was really not that. We got really lucky. Like, we started on GCP, and we started on GCP because Shopify ran on GCP. And so that was the platform I was most available with, right? And I knew the Canadian team there because I'd worked with them at Shopify. And so it was natural for us to start there. And so when we started building the database, we're like, oh yeah, we have to build we really thought we had to build a consensus layer, like have a zookeeper or something to do this. But then we discovered the compare and swap. It's like, oh, we can kick the can. Like we'll just do metadata.json and just, it's fine. It's probably fine. And we just kept kicking the can until we had very, very strong conviction in the idea. And then we kind of just hinged the company on the fact that S3 probably was going to get this. It started getting really painful in like mid 2024 because we were closing deals with Notion actually that was running in AWS. And we're like, trust us, you really want us to run this in GCP? And they were like, no, I don't know about that. Like we're running everything in AWS. And the latency across the clouds were so big. And we had so much conviction that we bought like, dark fiber between the AWS regions in Oregon, like in the inter-exchange. And GCP is like, we've never seen a startup like do like what's going on here. And we're just like, no, we don't want to do this. We were tuning like TCP, Windows, like everything to get the latency down because we had so high conviction in not doing like a metadata layer on S3. So those were the three conditions, right? Compare and swap to do metadata, which wasn't in S3 until late 2024. S3 being consistent, which didn't happen until December 2020. And then NVMe SSDs, which didn't land in the cloud until 2017.
I mean, in some ways, like a very big like cloud success story that like you were able to like put this all together, but also doing things like buying dark fiber. That actually is something I've never heard.
I mean, it's very common when you're a big company, right? You're like connecting your own like data center or whatever, but it's like, it was uniquely just a pain with Notion because like most of the, like if you're buying in Ashburn, Virginia, right? Like US East, the Google, like the GCP and AWS data centers are like within a millisecond on each other on the public exchanges. But in Oregon, uniquely, the GCP data center sits like a couple 100 kilometers like east of Portland, and the AWS region sits in Portland. But the network exchange they go through is through Seattle. So it's like a full like 14 milliseconds or something like that. And so anyway, yeah, it's so we were like, okay, we have to go through an exchange in Portland. Yeah. Anyway.
And you'd rather do this than like run your zookeeper and like...
Yes, way rather. It doesn't have state. I don't want state in two systems. And I think all of that is just informed by Justine, my co-founder, and I had just been on call for so long. And the worst outages are the ones where you have state in multiple places that's not syncing up. So it really came from a very pure source of pain of just imagining what we would be okay being woken up at 3 a.m. about, and having something in Zookeeper was not one of them.
When you're talking to like a Notion or something, do they care? Or do they just...
They just cared about latency.
Latency, cost, that's it.
They just cared about latency, right? And we just absorbed the cost. We're just like, we have high conviction in this. At some point, we can move them to AWS, right? And so we just... We'll buy the fiber. It doesn't matter, right? And it's like $5,000. And usually when you buy fiber, you buy like multiple lines, and we're like, we can only afford one. But we will just test it that when it goes over the public internet, it's like super smooth. And so we did a lot of, anyway, it was.
That's cool.
You can imagine talking to the GCP rep and it's like, no, we're going to buy because we know we're going to churn. We're going to churn from you guys and go to AWS in like 6 months. But in the meantime, we'll do this. This
workload still runs on GCP for what it's worth, right? Because it was so reliable. So it was never about moving off GCP. It was just about, honestly, it was just about giving Notion the latency that they deserved, right? And we didn't want them to have to care about any of this. They were like, oh, egress is going to be bad. It was like, okay, screw it. Like, we're just going to like VPC peer with you in AWS. We'll eat the cost. Yeah, whatever needs to be done.
And what were the actual workloads? Because I think when you think about AI, it's like 14 milliseconds. It's like really doesn't really matter in the scheme of like a model generation.
Yeah. We were told the latency, right, that we had to beat.
Oh, right.
So we're just looking at the traces, right? And then sort of like kind of like looking at the trace and then thinking, what are the other extensions of the trace, right? And there's a lot more to it because it's also, if you have 14 versus 7 milliseconds, right, you can fit another round trip. So we had to tune TCP to try to send as much data in every round trip, pre-warm all the connections. And there's a lot of things that compound from having these kinds of round trips. But in the grand scheme, it was just like, well, we have to beat the latency of whatever we're up against.
Which is like, Notion is a database company. They could have done this themselves. They do lots of database engineering themselves. How do you even get in the door? Like, yeah, just like talk through that kind of
Last time I was in San Francisco, I was talking to one of the engineers actually, who was one of our champions at Notion, and they were just trying to make sure that the per user cost matched the economics that they needed. Like it's like the way I think about it is like I have to earn a return on whatever the clouds charge me, and then my customers have to earn a return on that. And it's like very simple, right? And so there has to be gross margin all the way up, and that's how you build the product. And so then our customers have to make the right set of trade-offs that Turbopuffer makes, and if they're happy with that, that's great.
Do you feel like you're competing with build internally versus buy, or buy versus buy?
Yeah, so sorry, this was all to build up to your question. So one of the Notion engineers told me that they'd sat and probably on a napkin, like drawn out, like, why hasn't anyone built this? And then they saw Turbopuffer and was like, well, it's literally that. So, and I think AI has also changed the buy versus build equation in terms of, it's not really about, can we build it? It's about, do we have time to build it? And I think they felt like, okay, if this is a team that can do that and they feel enough of like an extension of our team, well, then we can go a lot faster, which would be very, very good for them. And I mean, they put us through the test, right? Like we had some very, very long nights to do that POC. And they were really our second big customer after Cursor, which also was a lot of late nights, right?
Yeah, I mean, should we go into that story, the sort of Cursor story? Like a lot, they credit you a lot for working very closely with them. So I just want to hear, like, I've heard this story from Swale's point of view, but like, I'm curious what it looks like from your side.
I actually haven't heard it from Swale's point of view. So maybe you can now cross-reference it. The way that I remember it was that the day after we launched, which was just, I'd worked the whole summer on the first version. Justine wasn't part of it yet because I didn't tell anyone that summer that I was working on this. I was just locked in on building it, because it's very easy otherwise to confuse talking about something to actually doing it. And so it's just like, I'm not going to do that. I'm just going to do the thing. I launched it. And at this point, Turbopuffer is like a Rust binary running on a single 8-core machine in a tmux instance. And me deploying it was like looking at the request log and then like command seeing it or like control seeing it to just like, okay, there's no request, let's upgrade the binary. Like it was like literally the scrappiest thing you could imagine. It was on purpose because just like at Shopify, we did that all the time. Like we we ran things in tmux all the time to begin with before something had like at least the inkling of PMF. So it's like, okay, is anyone going to care about this? And one of the Cursor co-founders, Arvid, reached out and he just, the Cursor team are like all IOI, IMO, like contenders, right? So they just speak in bullet points and facts. So it's like this amazing email exchange just of, this is how many QPS we have, this is what we're paying, this is where we're going, blah, blah, blah. And so we're just conversing in bullet points. And I tried to get a call with them a few times, but they were like really riding the PMF bull here, just like late 2023. And one time Swale emails me at like 4 a.m. Pacific time, saying like, hey, are you open for a call now? And I'm on the East Coast and it was like 7 a.m. I was like, yeah, great, sure, whatever. And we just started talking and something then, I didn't know anything about sales. Something just compelled me, I have to go see this team. Like there's something here. So I went to San Francisco and I went to their office. And the way that I remember it is that Postgres was down when I showed up at the office. Did Swale tell you this? No, okay. So Postgres was down. And so it's like they were distracted with that. And I was trying my best to see if I could help in any way. Like I knew a little bit about databases, back to tuning auto vacuum. It's like, I think you have to tune auto vacuum, Swale. And so we talked about that. And then that evening just talked about like, what would it look like? What would it look like to work with us? And I just said, look, like we're all in. Like we will just do we'll do whatever you tell us, right? They migrated everything over the next like week or two and we reduced their cost by 95%, which I think like kind of fixed their per user economics. And it solved a lot of other things. And we were Justine, this is also when I asked Justine to come on as my co-founder. She was the best engineer that I ever worked with at Shopify. She lived 2 blocks away and we were just, okay, we're just gonna get this done. And we did. And so we helped them migrate and we just worked like hell over the next like month or two to make sure that we were never an issue. And that was the Cursor story. Yeah.
And is code a different workload than normal text? I don't know. Is it just text? Is it the same thing?
Yeah. So Cursor's workload is basically they will embed the entire code base, right? So they will like chunk it up in whatever they do. They have their own embedding model, which they've been public about, and they find that on their evals there's one of their evals where it's like a 25% improvement on a very particular workload. They have a bunch of blog posts about it. I think it works best on larger code bases, but they've trained their own embedding model to do this. And so you'll see it. If you use the cursor agent, it will do searches. And they've also been public around how I think they post-trained their model to be very good at semantic search as well. And that's how they use it. And so it's very good at like, can you find me other code that's similar to this or code that does this and just in just queries. They also use grep to supplement it.
Yeah.
Of course.
It's been a big topic of discussion. Like, is RAG dead because grep? You know.
And I mean, like, we see lots of demand from the coding companies,
search
right?
In every part, yes.
We see demand, and so I mean, I like case studies. I don't like just doing like thought pieces on this is where it's going and like trying to be all macroeconomic about AI. That's has turned out to be a giant waste of time because no one can really predict any of this. So I just collect case studies, and I mean, Cursor has done a great job talking about what they're doing, and I hope some of the other coding labs that use Turbopuffer will do the same. But it does seem to make a difference for particular queries. I mean, we can also do text, we can also do regex, but I should also say that Cursor's like security posture into Turbopuffer is exceptional, right? They have their own embedding model, which makes it very difficult to reverse engineer. They obfuscate the file paths. It's very difficult to learn anything about a code base by looking at it. And the other thing they do too is that for their customers, they encrypt it with their encryption keys in Turbopuffer's bucket. So it's really, really well designed.
And so this is like extra stuff they did to work with you because you are not part of Cursor.
Exactly.
And this is just best practice when working in any database, not just you guys. Okay, yeah, that makes sense. Yeah, I think for me, like the learning is kind of like all workloads are hybrid. Like, you know, like you want the semantic, you want the text, you want the regex, you want SQL. I don't know. But like it's silly to like be all in on like one particularly query pattern.
I think like I really like the way that that Swale at Cursor talks about it, which is I'm gonna butcher it here. And you know, I'm a database scalability person. I don't know anything about training models other than what the internet tells me. And the way he describes is that this is just like cache compute, right? It's like you have a point in time where you're looking at some particular context and focused on some chunk, and you say, this is the layer of the neural net at this point in time. That seems fundamentally really useful to do cache compute like that. And how the value of that will change over time, I'm not sure, but there seems to be a lot of value in that.
But maybe talk a bit about the evolution of the workload, because even like search, like maybe 2 years ago, it was like one search at the start of like an LLM query to build the context. Now you have agentic search, however you want to call it, where like the model is both writing and changing the code and it's searching it again later. Yeah, what are maybe some of the new types of workloads or like changes you've had to make to your architecture for it?
I think you're right. When I think of RAG, I think of, hey, there's an 8,000 token context window and you better make it count. And search was a way to do that. Now, yeah, everything is moving towards just let the agent do its thing, right? And so back to the thing before, right? The LLM is very good at reasoning with the data. And so we're just a tool call, right? And that's increasingly what we see our customers doing. What we're seeing more demand from our customers now is to do a lot of concurrency, right? Like Notion does a ridiculous amount of queries in every round trip just because they can. And I'm also now, when I use the Cursor agent, I also see them doing more concurrency than I've ever seen before. So a bit similar to how we designed the database to drive as much concurrency in every round trip as possible. That's also what the agents are doing. So that's new. It means just an enormous amount of queries all at once to the data set while it's warm in as few turns as possible.
Can I clarify one thing on that?
Yes.
Are they batching multiple users or one user is driving multiple queries?
One user driving multiple, right. One agent driving.
Parallel searching a bunch of things.
Exactly. Yeah.
So exactly. Cognition also did this for the fast context thing, like 8 parallel at once.
Yes.
And like an interesting problem is, well, how do you make sure you have enough diversity so you're not making the same request 8 times?
And I think like that's probably also where the hybrid comes in, where that's another way to diversify. It's a completely different way to do the search. That's a big change, right? So before it was really just like one call and then, you know, the LLM took however many seconds to return. But now we just see an enormous amount of queries. So we just see more queries. So we've like tried to reduce we've reduced query pricing. This is probably the first time actually I'm saying that, but the query pricing is being reduced like 5x. And we'll probably try to reduce it even more to accommodate some of these workloads of just doing very large amounts of queries. That's one thing that's changed. I think the write ratio is still very high, right? Like there's still an enormous amount of writes per read, but we're starting probably to see that change if people really lean into this pattern.
Can we talk a little bit about the pricing? I'm curious because traditionally a database would charge on storage, but now you have the token generation that is so expensive where like the actual value of like a good search query is like much higher because they're like saving inference time down the line. How do you structure that as like, what are people receptive to on the other side too?
Yeah, the Turbopuffer pricing in the beginning was just very simple. The pricing for search engines before Turbopuffer was very serverful, right? It was like, here's the VM, here's the per hour cost, right? Great. And I just sat down with like a piece of paper and said like, if Turbopuffer is like really good, this is probably what it would cost with a little bit of margin. And that was the first pricing of Turbopuffer. And I just like sat down and I was like, okay, like this is like probably the storage amp or whatever on a piece of paper. And
It was vibe pricing.
it was very vibe price and I got it wrong.
Oh.
Well, I didn't get it wrong, but like Turbopuffer wasn't at the first principle pricing, right? So when Cursor came on Turbopuffer, it was like I didn't know any VCs. I didn't know, like, I just like, I didn't know anything about raising money or anything like that. I just saw that my GCP bill was a lot higher than the Cursor bill. So Justine and I were just like, well, we have to optimize it. And I mean, to the chagrin now of the VCs, it now means that we're profitable because we've had so much pricing pressure in the beginning because it was running on my credit card. And Justine and I had spent like tens of thousands of dollars on like compute bills and like spinning off the company and like very like bad Canadian lawyers and like things like to like get all of this done because we didn't know, right? If you're like steeped in San Francisco, you just know, okay, like you go out, raise a pre-seed round. I never heard the word pre-seed at this point in time.
When you had Cursor, you had Notion, you had no funding.
With Cursor, we had no funding. Yeah. By the time we had Notion, Lachy was here. Yeah. So it was really just, we vibe priced it 100% from first principles, but it was not performing at first principles. So we just did everything we could to optimize it in the beginning for that, so that at least we could have like a 5% margin or something. So I wasn't freaking out because Cursor's bill was also going like this as they were growing. And so my liability and my credit limit was like actively like calling my bank. It's like, I need a bigger credit. Like it was, yeah, anyway, that was the beginning. Yeah. But the pricing was, yeah, like storage, writes, and query, right? And the pricing we have today is basically just that pricing with duct tape and spit to try to approach like, you know, like a margin on the physical underlying hardware. And we're doing, this year, you're gonna see more and more pricing changes from us. Yeah.
And like, how much does stuff like VPC peering matter because you're working in an AWS land where egress is charged and all that, you know?
We probably don't, like, we have like an enterprise plan that just has like a base fee because we haven't had time to figure out SKU pricing for all of this. But I mean, yeah, you can run Turbopuffer either in SaaS, right? That's what Cursor does. You can run it in a single tenant cluster, so it's just you. That's what Notion does. And then you can run it in BYOC, where everything is inside the customer's VPC. That's what, for example, Anthropic does.
What I'm hearing is that this is probably the best CRO job for somebody who can come in and help you with this.
Like, Turbopuffer hired, like, I don't know what number this was, but we had a full-time CFO as like the 12th hire or something at Turbopuffer. I think I hear a lot of companies, I don't know how they do it, like they have 100 employees and not a CFO. It's like having a CFO is like
you're running a business, man. Like, you know,
it's so good. Yeah. Like Money Mike, like he just, you know, just handles the money and a lot of the business stuff. And so he came in and just helped with a lot of the operational side of the business. So like COO, CFO, like somewhere in between.
Just a quick mention of Lachy, just because I'm curious. I've met Lachy and like he's obviously a very good investor now in physical intelligence. I call it a generalist super angel, right? He invests in everything. And I always wonder, like, you know, is there something appealing about focusing on developer tooling, focusing on databases, going like, I've invested for 20 years in databases versus being like a Lachy where he can maybe like connect you to all the customers that you need?
This is an excellent question. No one's asked me this. Why Lachy? Because there's a couple of people that we were talking to at the time. And when we were raising, we were like a bit distressed because one of our peers had just launched something that was very similar to Turbopuffer. And someone just gave me the advice at the time of just choose the person where you just feel like you can just pick up the phone and not prepare anything and just be completely honest. And I don't think I've said this publicly before, but I just called Lachy and was like, look, Lachy, like, if this doesn't have PMF by the end of the year, like, we'll just like return all the money to you. But it's just like, Justine and I don't want to work on this unless it's really working. So we want to give it the best shot this year. And like, we're really going to go for it. We're going to hire a bunch of people and we're just going to be honest with everyone. Like, when I don't know how to play a game, I just play with open cards. And Lachy was the only person that didn't freak out. He was like, I've never heard anyone say that before. As I said, I didn't even know what a seed or pre-seed round was like before, probably even at this time. So I was just like very honest with him. And I asked him like, Lachy, have you ever invested in a database company? He was just like, no. And at the time I was like, am I dumb? Like, but I think there was something that just like really drew me to Lachy. He is so authentic, so honest, like, and there's something just like, I just felt like I could just play, like just say everything openly. And that was, I think that was like a perfect match at the time. And honestly still is. He was just like, okay, that's great. This is like the most honest, ridiculous thing I've ever heard anyone say to me. But like that.
Well, why is it ridiculous to say competitor launch, this may not work out?
It was more just like, if this doesn't work out, I'm going to close up shop by the end of the year, right? Like it was, I don't know, maybe it's common. I don't know. He told me it was uncommon. I don't know. That's why we chose him. And he'd been phenomenal. The other people we were talking at the time were database experts. Like knew a lot about databases and Lachy didn't. This turned out to be a phenomenal asset, right? Justine and I know a lot about databases. The people that we hired know a lot about databases. What we needed was just someone who didn't know a lot about databases, didn't pretend to know a lot about databases, and just wanted to help us with candidates and customers. And he did. Yeah. And I have a list, right, of the investors that I have a relationship with. And Lachy has just performed excellent in the number of sub-bullets of what we can attribute back to him. Just absolutely incredible. And when people talk about like no ego and just the best thing for the founder, I don't think that anyone, like even my lawyer is like, yeah, Lachy is like the most friendly person you will find.
Okay, this is the most glowing recommendation I've ever heard.
He deserves it. He's very special.
Yeah. Okay, amazing.
Since you mentioned candidates, maybe we can talk about team building, like especially in SF, it feels like it's just easier to start a company than to join a company. I'm curious your experience, especially not being in SF full time and doing something that is maybe, a very low level of detail and technical detail.
Yeah, so joining versus starting. I never thought that I would be a founder. I would start with it. Like Turbopuffer started as a blog post and then it became a project and then sort of almost accidentally became a company. And now it feels like it's like becoming a bigger company. That was never the intention. The intentions were very pure. It's just like, why hasn't anyone done this? And it's like, I want to be the first person to do it. I think some founders have this like, I could never work for anyone else. I really don't feel that way. Like, it's just like, I want to see this happen. And I want to see it happen with some people that I really enjoy working with. And I want to have fun doing it. And this has all felt very natural on that sense. So it was never a like join versus found. It was just this found me at the right moment.
Well, I think there's an argument for you should join Cursor, right? So I'm curious like how you evaluate it. Okay, I should actually go raise money, make this a company versus like, this is like a company that is like growing like crazy. It's like an interesting technical problem. I should just build it within Cursor and then they don't have to encrypt all this stuff. They don't have to obfuscate things. Like, was that on your mind at all? Or
before taking the small check from Lachy, I did have like a hard like look at myself in the mirror of like, okay, do I really want to do this? And because if I take the money, I really have to do it, right? And so the way I almost think about it is like, you kind of need to be like fucked up enough to want to go all the way. And that was the conversation where I was like, okay, this is going to be part of my life journey to build this company and do it in the best way that I possibly can. Because if I ask people to join me, ask people to get on the cap table, then I have an ultimate responsibility to give it everything. And I think some people, it doesn't occur to me that everyone takes it that seriously. And maybe I take it too seriously. I don't know. But that was like a very intentional moment. And so then it was very clear, like, okay, I'm going to do this and I'm going to give it everything.
A lot of people don't take it that seriously. But
let's talk about, you have this concept of the P99 engineer. People are 10xing, everyone's saying, maybe engineers are out of a job. I don't know. But you definitely see a P99 engineer and I just want you to talk about it.
Yeah, so the P99 engineer was just a term that we started using internally to talk about candidates and talk about how we wanted to build the company. And, like everyone else is like, we want a talent-dense company. And I think that's almost become trite at this point. What I credit the Cursor founders a lot with is that they just arrived there from first principles of like, we just need a talent-dense team. And I think I've seen some teams that weren't talent dense and like seen the counterfactual run, which if you've been in a large company, you will just see that. Like it's just logically will happen at a large company. And so that was super important to me and Justine. And it's very difficult to maintain. And so we needed wording for it. And so I have a document called Traits of the P99 Engineer. And it's a bullet point list. And I look at that list after every single interview that I do. And in every single recap that we do. And every recap I end with some version of, I'm gonna reject this candidate, completely irregardless of what the discourse was, because I wanna see people fight for this person. Because the default should not be, we're gonna hire this person. The default should be, we're definitely not hiring this person. And if everyone was like, I'll maybe throw a punch, then this is not the right.
Do you operate like if there's one, there must have at least one champion who's like, yes, I will put my career on the line for this,
I think career on the line.
Maybe he's not a champion.
Yeah, I would say someone needs to like have both fists up and be like, I'd fight, right?
Yeah.
And if one person said, then okay, let's do it, right?
Yeah.
And it doesn't have to be absolutely everyone, right? And like the interviews are always designed that you're checking for different attributes. And if someone is like knocking it out of the park in every single attribute, that's fairly rare. But that's really important. And so the traits of the P99 engineer, there's lots of them. There's also the traits of the triple nine engineer and the quadruple nine engineer, right? This is like, it's a long list.
Okay.
I'll give you some samples, right, of what we look for. I think that the P99 engineer has some history of having bent like their trajectory or something to their will, right? Some moment where it was just, they just, made the computer do what it needed to do. There's something like that. And it will occur to them at some point in their career and hopefully multiple times, right?
Give me an example of one of your engineers that like.
I'll give an so we launched this thing called ANN V3. We're working on V4 and V5 right now, but ANN V3 can search 100 billion vectors with a P50 of around 40 milliseconds and a P99 of 200 milliseconds. Maybe other people have done this. I'm sure Google and others have done this, but we haven't seen anyone, at least not in like a publicly consumable SaaS that can do this. And that was an engineer, the chief architect of Turbopuffer, Nathan, who more or less just bent this. The software was not capable of this, and he just made it capable for a very particular workload in like a 6 to 8 week period with the help of a lot of the team, right? There's numerous of examples of that like at Turbopuffer, but that's like really bending the software and x86 to your will. It was incredible to watch. You want to see some moments like that.
Isn't that 999?
I think
what's quadruple nine? That was all Nathan's banging nine.
I feel like this is too high for Nathan.
Nathan is like, yeah, there's a lot of nines after that P. So I think that's one trait. I think another trait is that the P99 spends a lot of time looking at maps. Generally, it's their preferred UX. They just love looking at maps. You ever seen someone who just like sits on their phone and just like scrolls around on a map? Or did you not look at maps a lot? You guys don't look at maps?
I guess I'm not feeling there. I don't know, but
you just disqualify. What about trains? Do you like trains?
I mean, they're
not enough.
Okay, this is just like weaponized autism, is what I call it.
I love looking at maps. Like it's like my preferred UX, and just like I like lots of.
Like is it of like random places?
So like
Yes. Okay. There you go.
So instead of like random places, like how do you explore the maps?
No, it's just a joke. But
it's autism. Unless it's like you are just obsessed by something and you like studying a thing.
The origin of this was that at some point I read an interview with some IOI gold medalist, and it's like, what do you do in your spare time? It's just like, I like looking at maps. And I was like, I feel so seen. Like I just like love like strolling out. I was like, oh, Canada is so big. Where's Baffin Island? Like, I don't know. I love it.
Yeah.
Anyway, so those traits of P99. P99 is obsessive, right? Like there's just like you'll find traits of that. We do an interview at Turbopuffer, or like multiple interviews that just try to screen for some of these things. So There's lots of others, but these are the kinds of traits that we look for.
I'll tell you, some people listen for like some of my DevRel stuff. I do think about DevRel as maps. You draw a map for people. Maps show you the what is commonly agreed to be the geographical features of what a boundary is, and it also shows you what is not doing. And I think a lot of like developer tools companies try to tell you they can do everything, but like let's be real. Like your 3 landmarks are here. Everyone comes here, then here, then here, and you draw a map, and then you draw a journey through the map, and like that to me that's what developer relations looks like. So I do think about things that way.
I think the P99 thinks in trade-offs, right? The P99 is very clear about, hey, Turbopuffer, you can't run a high transaction workload on Turbopuffer, right? It's like the right latency is 100 milliseconds. That's a clear trade-off. I think the P99 is very good at articulating the trade-offs in every decision, which is exactly what the map is in your case, right?
Yeah. My world.
How do you reconcile some of these things when you're saying you bend the will of the computer versus like the trade-offs? I think sometimes it's like, well, these are the trade-offs, but the 3 nines is like actually is not a real trade-off because we can make something that nobody has ever made before and actually make it work.
The way I think about the bending trajectory to your will is if you sit down and do the napkin math, right, where you're just like, okay, like if I have 100 machines, they have this many terabytes of disk, they have this bandwidth, whatever, right? And you sit down and you just do the like high school napkin math on this is how many QPS we should be able to drive to it, similar to how I did the vibe pricing, right? If you can sit down and do that, and then you observe the real system and you see, oh, we're off by like 10x, bending trajectory to your will is like just making the software get closer and closer to that first principle line. The P99 might even be able to cross the line, right, by finding even more optimizations than from first principle. So bending the software to your will is about that, right? Like 100 millisecond P99 to S3, I mean, now you're talking like someone really high agency that like goes to Seattle, finds the S3 team, and it's like, how are we going to make this 10? Like that's not quite what we talk about, right? But yeah.
What's the future of Turbopuffer?
Turbopuffer started out, Act 1 of Turbopuffer was vector search. That was all we did to begin with. Act 2 of Turbopuffer is and was full text search. Turbopuffer today has a fairly state-of-the-art full text search engine. We beat Lucene on some queries, in particular, very long queries that we've optimized for because those are the text search queries we see today. They're generated by LLMs or augmented by LLMs, and we see them on web scale data sets, right? Like someone searching for a very long text string on all of Common Crawl. We beat Lucene on some of those benchmarks, and we expect to continue to beat Lucene on more and more queries. That's the performance and scale. Turbopuffer does phenomenally now at full text search performance and scale. What we work on now is more and more features for full text search. People expect a lot of features with full text search. And full text search is still very valuable, right? If you go in and you press Command K and you search for SI, an embedding-based search might be like, oh, this is something agreeable because that's C, that's yes in Spanish, right?
But in Italian too.
But in full text search, that's the prefix of maybe a document of like, these are all the reasons I hate Simon, right? Like this is like, that's a completely different. So that augmentation to like how the human brain works and mapping like data to user is very important, but it's a lot of features. That feature grind is what we're firmly on. And you will see us just adding to the changelog every month, just more and more full text search features. So we're like fully compatible. And we're seeing people move from some of the traditional search engine onto Turbopuffer for that. That's a big focus of Turbopuffer this year. The other focus of Turbopuffer this year is just on scale. We're seeing more and more companies that want to search basically Common Crawl level types of data sets. Both internally at companies and externally at a time, like query like 100 billion vectors or 100 billion documents at once. This is tricky, and we want to make it cheaper and we want to make it faster. That's a big focus for Turbopuffer this year. That's, we just released ANN v3, which we talked about before. We're working on ANN v4, and we're also have planned what we're going to do with ANN v5, right? And then on full text search, we're working on a lot of these features. Will be like FTS v3, but it will all roll out incrementally. Those are some of the really big features. And then the other thing is our dashboard. Have any of you ever logged into the Turbopuffer dashboard? There's not very much there. It almost looks like if a founder 2 years ago just sat down and wrote enough dashboard that there was at least something there, and then other people just sort of added stuff on for the next the following 2 years, and then at some point SSO and other things to just catch up. And it may or may not be what happened, but adding I want PHP my admin back. Like, do you guys remember? Like, it was so good, right? And I think that software hardware integration between the dashboard of the console of the database and the database itself, I'm really excited for that. There's lots of other things that are going to come out in the next, like we talked a bit about some pricing and things like that, but those would be some of the big hitters right now.
You talk about eras of like Turbopuffer. I have to ask, like, yes, there's the stuff that you're working on this year, but like, I'm sure in your mind you already have the next phase that you're already thinking about.
Act 3?
Yes.
Act 4?
Yeah.
Act 5. What I was saying about
what are the candidates? You don't have to decide.
Yeah.
Now, but
I'll just say that if you want to build a big database company, the database over time has to implement more or less every query plan. Because when you have your data in a database, you expect it to, over time, not just search, but also, hey, I want to aggregate this column. I want to join this data, all of that. But when you're a startup, your only moat is really just focus. So you have to lay out the tasks and you have to not get overeager. And I think we've seen some of our peers get very overeager and overextend themselves. And what I keep telling the team, I was just having breakfast this morning with our CTO and chief architect, and we were talking about like, what we're most likely to regret at the end of the year is having tried to do too much. And so Act 3 candidates could be, a bunch of simpler OLAP queries, right? It could be lending ourselves a little bit more into, we see some people who want to do traces and logging and things like that, some very simple use cases. Could be that, right? It could be maybe some time series. Some people are trying to do that, right? Like there's lots of different things that you can do with Turbopuffer. But for now, if you're trying to do not search on Turbopuffer as the primary use case, you probably shouldn't. But we see some customers that are like, like at some point Cursor moved like 20 terabytes of Postgres data into Turbopuffer because it's there, it works, and these particular query plans we know work well, and so they just moved it all to defer sharding. So we look for patterns like that in what future acts of Turbopuffer are going to be before firmly doubling down on them. But we wouldn't, if you're using Turbopuffer, it should be because search is very important to you. And then we might do a lot of auxiliary queries to that, but that should not be the main reason to go to Turbopuffer at this point in time.
Yeah. You didn't mention, one thing I was looking for was graph type queries, like graph database, graph queries. Can you basically trivially replicate this with what you already have?
We see some people doing that.
Right, because you have parallel queries and it's the same thing.
Exactly. So we see some people doing that, right? Like Turbopuffer is just a KV, right? And then we expose things on top of it. So we are seeing people do that. And I think, our roadmap is very much just the database that connects AI to a very large amount of data is what the path is to do that in the right order, which is what a good startup is around. What is the order to do things in? Our customers are P99, and they will tell us what they care most about next. And so some of them are doing graphs now, and if they need more graph database features, they'll be banging our door, and we'll prioritize accordingly.
Okay, give us the tea. You kindly gifted us your favorite tea. This is Yabukita Kamaricha from the Green Tea Shop.
That's right.
Talk about your love of tea.
Yeah, we were just talking beforehand about caffeine, I think. And especially when I'm on a trip like this to San Francisco, I consume a lot of caffeine. But this is my preferred caffeine. It's this green tea. I have an Airtable with 200 teas that I've tried over time, over the past 15 years. And this one is my favorite. Now, when you drink a tea, there's 6 different types of tea. I like green tea. In particular, I generally prefer Chinese green tea. And I don't really like Japanese green tea. But this little prefecture somewhere in Japan has specialized in, they're like Japanese, but doing it the Chinese way. And it's just phenomenal. But then the interesting thing about the tea world is that all of the different, you can find this particular tea. There's probably, hundreds of places that sell it, but they all go to a different family, right? On whatever mountain that they have these Camellia sinensis bushes on. And this woman, Japanese woman in Toronto from the green tea shop, I don't know, she just has found a really good family because that's the best one. The best time of year to get this is in a few months when they do the spring harvest. Now it's kind of old. It's just I love the spring for the fresh tea. So I hope you enjoy it, but it's not the right time of year.
It's out of season. Yeah, I actually didn't even know T has seasons. So this is how unsophisticated I am. But I think it ties in with loving maps and being obsessed and being P99 in everything that you do. Yeah, but that's great.
Awesome. Well, as we were saying, we have instant hot water at Kernel. So MET lover can come by any.
I have a little tea kit where I bring like a little thermometer too, like a little ThermoWorks thermometer. Last Friday when we do demos, I have this thing where if there's not enough demos, then I fill the remaining time talking about something completely ridiculous as an incentive for people to actually demo. And last time I spent 20 minutes walking through my Airtable and going through my entire tea travel kit, including the temperature monitor. Because you show up, there's only a boiler, you can't get it to the right.
Yeah.
You need this at 80 degrees. But anyway, yeah, sorry.
Yeah. We have an electric kettle with the temperature thing at home.
I would watch this. You should start a company YouTube, but it doesn't have anything about search. It just has tea and other rants.
I don't think I could talk, but something that I started doing. Do you two know Sam Lambert of Planet Scale?
Of course. Very outspoken guy.
I love the guy, and we just last week we just went on X Live and just sat and shut the shit for an hour. And I think we'll probably do that again. Yeah, so we'll probably come up there. Well, I don't know what we'll call it. Maybe P99 Live or the P99 Pod or something like that.
P-Pod.
P-Pod.
Cool. Well, thank you so much for your time. I know you have to go, but this is a blast, and you're clearly very passionate and charismatic. So I bet you'll get some P99 engineers out of this podcast.
Yeah.
Thank you so much for having me. It was a pleasure.